So we left off last class. We talked about the area of rectangles and triangles and even the area and circumference of circles. So today, and we even did some composite shapes where we fit them together, I want to start out with a problem today where we do have to think about this a little bit. That's a half circle. Oops. That's a rectangle. And another half circle. Let's say this is 100 feet total, and this to here is 60 feet. Find the area of that for me.
Of what?
Of the whole thing. This whole thing. Yeah. Do we know a radius of the circle, of that half circle? Do we know how big this is across here? No, it's not 60. It's 60 from here to here. It's not a square. It's a rectangle. If it had said square, you'd been right. Well, if this is 100 and this is 60, how much is left over? 40. Assuming that these then are identical, which they have to be, it's 20 on each end, correct? So that makes that a radius of 20. If that's a radius of 20, it makes it a diameter of 40. So it's 40 feet that way. What's that? How did I go from 20 here to 40 there? Because it's 20 from here to here. That's just a radius, right?
Okay.
A diameter is twice the radius.
Oh.
So it's 40. So that makes this rectangle 60 by 40. Otherwise known as 2,400 square feet. This now I have two half circles. If I chop them off, I get one circle with a radius of 20 feet. Its area will be pi times 20 squared. Otherwise known as 1,256 square feet. So that makes this whole thing 3,656 square feet. What do you think? Okay, I know. We'll go over that again.
If I basically get it right, so the radius is 20, and the length of that is twice the radius. But then you combine the circle.
Let's go over it again. We have a rectangle, right? That was 60 feet this way. That's all I gave you. On the end of the rectangle was a half circle on each end. The total length 100. So the difference between the 100 and the 60, of course, is 40 feet, which has to be split evenly to 20 and 20. And that's how you get that the radius of that circle has to be 20 feet. Yeah.
So you subtract 100 from 60, what has to be left has to be equal.
No. Yeah, exactly. You're right. What's left has to be split evenly, 20 and 20. Now I can take, this is a half circle here, right? And a half circle here. I can put them together and make one full circle. Has a radius of 20, which means it has a diameter of 40, because the diameter is twice the radius, which means coming back here, this diameter here is 40 feet. So that gave us a rectangle here that was 60 by 40. That's where we got the 2,400 square feet. 60 feet times 40 feet. Now, that circle that we made from the two half circles, its area is just pi times the radius squared. So pi times 20 squared. 20 squared is 400 times pi is 1,256. And you add them up. It does kind of, doesn't it? Let's throw another fun one out there. No, not yet. Let's do this one. What I want here is the area of the donut ring.
Okay. The inside is twice the radius.
What we have is two circles. This inner circle has a radius of 8. What's the radius of the outer circle?
14.
14. Good. Where'd that come from? 8 plus 6. Good. So I've got a big circle with a radius of 14. Its area is pi times 14 squared. 3.14 times 14 squared. 615.44. Now we've got to find that little circle and subtract it out. Its area will be pi times 8 squared. Otherwise known as $200.96. Correct? If we're using 3.14 for pi. So we subtract, we get 414.48 square feet, correct? Whew.
So basically, that donut is the deck
Yes.
around the pool.
Yeah, deck around a pool or patio around a flower garden or however you want to do it. Now what? Well, sorry, I'm out of it. We're going to talk about volume. Volume. Now, we've all seen definitions of volume. I'm going to define volume a little bit differently. If you recall, when we defined area, I defined, for a rectangle, I defined a length, and then you took that length and you pulled it through a distance to create an area. And that area was that length times that distance, or it became a length times the width for a rectangle. For a volume, we're taking an area like this, and we're doing the same thing. We're moving it again. We're pulling it through space this time. And it has to be perpendicular to the original two directions. And if we started out with an area that was a rectangle, of course, it creates a box. And the volume is equal to the area of that original piece. We call that original piece the base. So it's the area of the base times the height or whatever distance it was that we moved it through. So if I have a base, and again, this is actually a rectangle. I'm just drawing it with the angles because you're kind of looking at it in 3D here. So let's say I have a base that is 12 feet by 7 feet. And I pull it up 10 feet tall. I want to find its volume. Well, the area of the base, come on, pull back here. There it is. The area of that base is 12 by 7, or 84 square feet. So then the volume will be that area of the base, 84 square feet, times a height of 10 feet. So 840 square feet times feet is cubic feet, or feet cubed. Now that's the formula most of you have seen is the volume of a box is length times width times height. Because the area of the base is just length times width. And it works out that way. But there's a very good reason why I define volume like this instead of as length times width times height. First of all, I'm going to have you guys try one. Yep.
missing a few people today.
Just a few. Okay, so on this one, let's say that this is 5 inches by 14 inches. By 15 inches. Find the volume of that for me. So what'd you get? Well, we've got the area of our base is going to be 14 times 5 inches to give us 70 square inches. So our volume is that 70 square inches times 15, which is 1,050 inches cubed. Sound right?
Why don't we just go 14 times 5 times 15 because it's the same thing?
Good question. You could do just 14 times 5 times 15, length times width times height. Here's why. How do you find the volume of that then? Well, we have a couple of choices. We could memorize a new formula, because there are formulas out there for the volume of a cylinder. But why do I want to memorize a new formula? Volume is area of a base times a height. What's the base of this? It's a circle with a radius of 4. So that area is pi times 4 squared, otherwise known as 50.24, and that's in inches, so this is inches squared. So now my volume is 50.24 inches squared times a height of 10 inches, otherwise known as 502.4 inches cubed. Yeah, really easy.
So you don't have to memorize new.
You don't have to memorize a new form. It's just area of a base times a height.
So it's base times height like normal prime. Then that will equal, for example, 70 times 50.
If that's your height, yes. Now, your base is not always the bottom. The base is the shape that the figure is based off of. So here, what is the base? Nope. But what shape can I take and pull through the whole object to create the object?
Oh,
The triangle. Very good. That's what the base is. The base isn't necessarily, we're so used to the base being the bottom. It isn't the bottom. The base is the shape that is used to create the solid or to create the object. So the area, oh, I got to put some dimensions in here, don't I? Let's say this is 5 feet, 12 feet, and 20 feet. The area of my base then here is 5 feet times 12 feet, but it's a triangle, so it's divided by 2 to give me 30 square feet. Everybody remember that formula for triangle? Base times height divided by 2? It's half the rectangle, so you got to divide it by 2. So then my volume is that 30 square feet times my height. Even though it's not really a height, it's a distance from one base to the other of 20 feet, which is 600 cubic feet.
Even though it's flat, you gotta see it as.
Yeah, as though you're standing it up on end like this. Yeah.
Yeah, it doesn't look at you.
I know, I drew it pretty crappy. In fact, it doesn't even have to be a regular shape on bottom. We could have something like this.
Actually, that could pressure on that.
Like that.
Wow. That's good.
Oops. Draw. First thing we got to do is we got to find the area of this base. Well, the area of that base is going to be 2 pieces now. First, First we have a rectangle here. It's 8 by 10. Or 80 square inches, or inches squared. Then we have this half circle here. What's the radius of that circle? What's it across here? 8, which is the diameter. So the radius would be 4. So it's pi times 4 squared, but that's only half a circle, which means I divide that in half. So that gives us 25.12 inches squared. Correct? Sure. So now we add that up, we get 105.12 square inches. Is the area of the base. So now the volume is simply 105.12 square inches times a height of 10 inches. So 1,051.2 inches cubed. See how easy that is to find volume with that definition? Because inches squared times inches is inches cubed. And volume is always inches cubed.
Okay, can you go past inches cubed?
Not in reality, no. Theoretically, you can. But there is no real inches to the fourth in a three-dimensional space.
Only the first dimensional.
You start talking about like modulus of elasticity and stuff like that, you'll get into inches to the fourth, but they're a theoretical unit, not a visible unit. It's used for calculating other properties of materials rather than... It's an engineering application.
I wonder what the fourth dimensional object is.
You want to know?
You can go in the,
So the next thing we need to talk about, surface area. Surface area. Let's go back to these boxes.
you know, it's really hard to use because I can't draw those cube things. So it makes it hard to...
You want to enter an easy way to draw those? Draw a rectangle like this. Go up a little ways, draw another rectangle like that, same size. Connect the corners.
Oh, sweet. Okay.
Surface area is the area of all the surfaces added together. Now on this, we could just do 12 times 20 to get this bottom piece. There's another one on top that's the same. 10 times 12 to get the end piece. Another one over here that's the same. 20 times 10 gives you the front, and the back is the same. So you can add up all 6 of the rectangles. But just like with volume, there's a simpler way to do it. There's a way that's going to work better for our other pieces. So what we're going to do is we're going to define the area of the bases again. Notice it said base is and not just base, right? Because there's a base on bottom, but the top is identical to it. So we have 20 inches by 12 inches, which is 240 square inches. And then there's another one on top that's identical to it. So 240 square inches is bottom and top. And then we're going to define something called lateral area, or lateral surface area, it's sometimes called. What the lateral area is the area that connects the bases. So that would be this front side here, this end, the back side, and this end over here. That's the lateral area. And the thing about the lateral area is, if we take a scissors and we cut up the corner here, the lateral area can almost always be unfolded into a big rectangle. So we have the front here. This is the first part of the rectangle. That's 20 inches here. And, of course, 10 inches high. Then we have the end here. That's going to be another 12 inches here. Still 10 inches high. Then the back is another 20 inches. Then the end here's another 12 inches. And, of course, they're all 10 inches high. Well, what's this dimension across here end up being? No, it's just the perimeter of our base. 20 plus 12 plus 20 plus 12 is the perimeter of our base. Nope, not divided by 2. So the perimeter of the base, if we add those all up, is 64. The lateral area, which is the area of this rectangle, is that length times this height of 10. So the lateral area is the perimeter of the base times the height. So for this figure, it's at 64 inches times that height of 10 inches makes an area of 640 square inches, or inches squared. So that has to be added to the area of our bases. 240 and 640 make 1120 square inches. That's our total surface area. Let's do another example of that, or two or three. So, surface area. First thing we need, area of the base, which is going to be how much? There's my base, which will be 13 by 10, correct? Why am I writing it down twice? Because the top is the same. Very good. Lateral area. What do I need to know? I need to know the height is 7 inches, and then I need to know the perimeter of the base is 13 plus 10 plus 13 plus 10. Otherwise known as 46 inches. And then, lateral area is 46 inches times 7 inches. Otherwise known as 336 square inches, correct? No, it's not. 322 square inches, yes. So that gets added to our list here. So 260, 582 square inches. That's our surface area. What you think? Better?
It doesn't need to be cubed.
No, because area, not volume. Area is squared, volume is cubed.
That's why you feel like this didn't just take the day off.
Well, I had to get through this lecture. I might go home after this class.
Oh my god.
I could not let you guys miss out on this. I would not feel right.
That's sick in itself.
Let's find the surface area of this. How, you might ask? Well, first step is the area of the bases. How do I find the area of the base here? Pi times 5 squared.
Oh, yeah.
5 squared would be 25, so pi times that is 78.5 square feet. And again, there's another one on top, so I'm writing it down twice. For lateral area, I know the height is 12, but I need to know the perimeter of the base. My base is a circle, which means the perimeter is a circumference.
So it's 75.
So it'll be pi times 10. Where'd the 10 come from?
The diameter.
Yeah, radius of 5 means the diameter of 10, and it's pi times diameter for circumference. So 31.4 feet is the perimeter of the base. which makes the lateral area 31.4 feet times the height of 12 feet.
And then like have more than one equal sign equation.
615.44. Yeah, they lied to you. So we add that up. $533.8 square feet. How's what possible? Did I subtract instead of add?
Yeah.
Why did I write down 615?
I have no idea.
It should be 376, shouldn't it? 0.8. The little hamster has made its way a long ways from the wheel, I think. I have no idea where that came from. 376.8. We add that up. It's 533.8.
Okay.
Yes, I am. Good news is there is a new quiz due tomorrow, otherwise known as Tuesday, at 11:59 p.m. There's a new homework due Wednesday in class.